Good afternoon, my YouTube viewers. It is Crystal here. I just wanted to make another technical video for you, and this video is going to be on hypothesis test. And what I wanted to know was, how do you know when to perform a two-tailed or a one-tailed test? And then when you're performing a one-tailed test, when do you know whether it's going to be a right side or a left side? Because you have three types of hypothesis test where you calculate the t-statistic. So one is a two-sided test, and one is a one-sided test right side, and one is a one-sided test left side. And so we need to know when is appropriate to make the best test. So the first test that we're going to have is going to be a two-sided test. And it's going to be an example where a battery has a lifespan of 300 hours. We're going to take a random sample of 30 batteries to measure their lifespans to see if they deviate from the expected lifespan of 300 hours. So your null hypothesis is the mean is 300 hours, and your alternate hypothesis is the mean is not 300 hours, since it is a two-tailed test. So for a two-tailed test, you check for any significant difference between the sample and the population. So this is done in Python, and we're using Google Colab to make this script. So we're going to import our libraries, which is numpy and scipy.stats. And so we're going to give our given data. It's going to be n, that's your sample size is 30. X bar, that's the mean of the sample, and that's 295. STD, that's your standard deviation, that's 15. Mu is the mean of the population. Alpha is your significance level, and it's 0.05. So we're going to calculate the standard error. SE equals STD divided by NP dot square root n. And then the standard error is going to be 2.73. And then we're going to calculate this t-statistic. So your t-statistic is X bar, that's your sample mean, minus mu, which is your population mean, divided by SE, that's your standard error. So your t-statistic is going to be negative 1.83. And now we're going to calculate the degree of freedom. Your degree of freedom equals n, that's your sample size, minus 1. So your degree of freedom is going to be 29. Now we calculate the critical t-value for a two-tailed test. T critical equals stats.t.ppf, and that's percentage point function. And then it's 1 minus alpha divided by 2, and then your degree of freedom, and your t critical is 2.05. And then we're going to calculate, we're going to determine if the t-statistic falls within the rejection region. So reject null equals ABS, that's absolute value, t-statistics greater than t critical. And then so the reject null hypothesis is going to be false. So so it means that you're not going to reject the null hypothesis. So the null hypothesis is the sample mean. There's no significant difference between the sample mean and the population mean. So interpretation, if reject null, that would be a true. Print there is evidence to reject the null hypothesis. Else, print there's not enough evidence to reject the null hypothesis. So we don't have enough evidence to reject the null hypothesis, so we're going to accept the null hypothesis. And so I printed off, I created a diagram of the t-distribution, and so you can see your t-distribution is in blue, your rejection region is in pink, your t-statistic is neg 1.83, and your negative t critical is negative 2.05. So you can see that your t-statistic is not in the rejection region. region, and since it's not in the rejection region, you cannot reject the null hypothesis, so you have to accept that null hypothesis. So the next test that we're going to study is going to be a one-tailed test on the right side. So we're going to have a software feature that is intended to reduce the average response time. The current average response time is 4.5 seconds. You want to take a sample of 25 responses to see if the new feature has reduced the average response time. And then your null hypothesis is 4.5 seconds, and your alternate hypothesis is less than 4.5 seconds. So it's a one-tailed right test. For a one-tailed right test, check B for a significant increase. So I don't think that. I wonder if the alternate hypothesis is greater than 4.5 seconds. So, because the null hypothesis is 4.5 seconds, and the alternate hypothesis is less than 4.5 seconds, and that's what you want. So let's see what we've got here. We've got, it's on the right side, so it says it's less than, so that's what we're going to go by for the time being. So we're going to import our libraries of NumPy and SciPy.stat, and so that's going to calculate your values. We've got a given data in, which is your sample size, is 25. X bar, which is your sample mean, is 4.2. Standard STD is your standard deviation at 0.3. Mu, which is your population mean, it's 4.5. Alpha, which is your significant level, is 0.05. And we're going to calculate the standard error, which is STD over the NP dot square root n. So let's see what our standard error is 0.06. We're going to calculate the t-statistic. So your t-statistics equals x bar minus mu divided by SE. So we're going to see what our t-statistic is. It's neg 1.83. No, I think that, no. It's neg 5. And then we're going to calculate our degree of freedom, which is n minus 1. So that's going to be 25 minus 1 is 24. Now we're going to calculate the critical t value for a one-tailed test. T critical equals stats.t.ppf. That's 1 minus alpha df. So our t critical is 1.71. And we're going to determine the t-statistic falls within the rejection region. Reject null if the t-statistic is greater than or equal to the t-critical. And then so we've got the reject null is false. That means it cannot reject it. And then we interpret that. If reject null is true, then you print there is enough evidence to reject the null hypothesis. If the reject null is false, you print there is not enough evidence to reject the null hypothesis. And then it's false, so we print there is not enough evidence to reject the null hypothesis. So we come over here and we look at the chart that I've made, the graph that I've made. So you see you've got your t-distribution in blue, your rejection region in pink, you've got your t-statistic, which is neg 5, and you've got your t-critical, which is 1.71, and you can see that the t-statistic does not fall within the rejection region, so you cannot reject the null hypothesis. So the next one that we're going to check is we're going to check the one-tailed test on the left side. And so we've got a question. We've got our hypothesis question, which is a pharmaceutical company has a medication that has a minimum concentration of 5 milligrams per dose. Ensure the concentration does not fall below this level. And then so you've got your null hypothesis is greater than or equal to 5 milligrams, and your alternate hypothesis is less than 5 milligrams, so it's a one-tailed left test. So for a one-tailed left test, check for a significant decrease in the sample mean. So the first thing we want to do is we want to import our libraries, and we're going to import NumPy and SciPy, and then we're going to set up our initial variables of n, that's your sample size of 20, x bar, which is your mean population, your sample mean is 4.8, standard deviation, which is STD, is 0.4, mu is your population mean of 5, alpha is your significance level of 0.05, and then we calculate the standard error, which is STD, that's over NP square root n. So your standard error is 0.089. Then we calculate the t-statistics. So the t-statistic equals brackets x bar minus mu brackets over SE, standard error. So we look at our t-statistic, and our t-statistic is -2.24. Now we check our degree of freedom. The degree of freedom is n-1, so that's 20 minus 1, which is 19. We're going to calculate the critical value. So t critical equals stats.t.ppf alpha, comma, df. So our critical value is 1.73, negative 1.73. And now what we do is we determine if the t-statistic falls in the rejection region. So reject null equals t-statistic is less than t-critical. So our reject null is true. So if the reject null is true, you print there is enough evidence to reject the null hypothesis, else there's not enough evidence to reject the null hypothesis. And then it's true. So that means the null hypothesis is rejected. So we look at the graph that I've made. You've got your t distribution in blue. You've got your rejection region in pink. You've got your t statistic, which is negative 2.24, and you've got your t critical, which is negative 1.73. So since the t statistic is less than the t critical, then that means that your null hypothesis has to be rejected. You cannot accept the null hypothesis. And so that's how it worked. And so those are the 3 examples that I've given you with graphs on how to do a 2-sample test, 1 sample test on the right side, and a 1 sample test on the left side. So I'm sure you can practice this, and you can practice this, and you can learn how to use the most appropriate test when needed. So thank you so much for watching my video. If you like my video, please like and subscribe. I look forward to making more technical videos for you in the near future.